Hi, my name is Kevin Blakesley and I work with Prime Turbines. Today I want to talk a little bit about the reverse cambox assembly on a PT6A-21 or a 28 or a 135 on a King Air F90, equipped with the factory 3-bladed propellers or 4-bladed propellers as such on the F90 or the A100. So a couple of things that I want to go over before we talk about the specifics of what happens behind the scenes is the actual names of the parts as they're called out in the IPC. So the nomenclature for this is the mounting bracket, obviously, the fuel lever. This particular one is pre 1486 and pre 1492. This is the reverse cam. I believe this is the follower lever, and this is the reverse actuating lever, fuel control actuating lever for reverse. Splined pin, straight pin, cam follower pin. Okay, so I guess I want to talk to you real quickly about the differences on this particular part. Should the rod end bearings seize on the 11-inch rod where it attaches either to here or in the fuel control seize in their bearing, should the bearings seize, what would happen is this would remain at power even though the pilot has pulled the power lever back. This would stay up. Okay, so 1486 and 1492 incorporates an additional ramp that extends upward behind this to force the cam follower pin to pull the actuating lever back to a lower power setting for control purposes. So that is Service Bulletin 1482. 1492 actually shortens this leg a little bit because there were some interferences with the cam follower pin hitting at flight idle. So they shortened the 1492 actuators. So what I want to do here real quickly is put it together, and I like to lube the parts with a light film of Lubriplate as I'm going together, but I'm going to omit it on this video so that I can move forward. But a little goes a long way, so you don't need to use a lot, just a small film. And then all of the cotter pins and washers are stainless. Try to use the Inconel. I believe it's a MS 9246-23 Inconel pins that go here. There seem to be a little stronger, and it's a pretty important part so I recommend using what's called out in the IPC. And again, for the spline shaft, a little bit of Lubriplate on there. Don't use a lot. This particular part always seems to get covered in dirt and crud. And then we'll put our screw for the cam follower lever on. It gets torqued to 36 to 40 inch-pounds. Lock wired with Inconel wire, 25 thousandths. And we'll put a little bit of Lubriplate on both of these surfaces, as well as the ramp. Just a little film of Lubriplate in here where the metal-to-metal contacts are happening, and also on the actuating lever. A little bit of Lubriplate in there. Okay. And we'll put our cam follower pin in. And there you have it. Now we'll put our return spring in, and the small outside diameter washers that Pratt calls out in the IPC. And again, we'll lock it down with Inconel cotter pins, as such. Oops. Anyway. Okay, so what I'm showing you is a cam box assembly that's on the King Air B in flight idle position. And you will notice that my index finger is on the actual reverse cam, but yet it's not moving when I rotate it back to flight idle. Okay, now if it was a STOL aircraft, it would come back a little bit. It would come back at flight idle, or before flight idle. And what that would do, by pulling on the rope, say 60 thousandths, is it would reset the propeller to a lower pitch for slowing the aircraft up and STOL type approaches. And there's a big difference between beta and reverse thrust, often confused. Resetting the propeller from a low power to a flight idle doesn't mean it's developing negative thrust. It just simply means it's a pitch that will work for the size and weight of the aircraft to give a comfortable approach speed for that particular aircraft. And you see it a lot on STOL aircraft such as the de Havilland Twin Otter. However, in the Twin Otter case, they do not utilize the Pratt & Whitney reverse cam, where they specifically have their own cam box that gets mounted up on a Dash 27 or a 34 engine. So anyway, the other responsible feature of this reverse cam box is the ability for this part right here. This is the fuel control actuating lever for reverse. And this particular screw will come in contact with the cam follower pin and add fuel, or pull on the 11-inch rod to add fuel at a point where the propeller is now just starting to develop negative thrust. That is at the point where you want to start adding fuel, and that is the feature of this adjustment right here. Secondly, it is also for timing and synchronizing twin engine applications, at which point fuel is then added. So it's doing two things. It's supporting enough fuel for the propeller to add gas at just the point where it starts developing negative thrust, and then secondly, it's used to synchronize twin engine application. So if you didn't have a reversible propeller, there would be no need for this part here. You simply would just hook the airframe control right to the fuel control unit, and that would be all that would need to happen. But since we're trying to control the pitch of the propeller and not change the NG speed, we want to do two things. Well, actually three things is what this is responsible for. Readjusting the pitch of the propeller at flight idle, and controlling the fuel control at how much power for a particular setting you're requiring. And then lastly, synchronizing when and how much power is going to be applied in reverse. So all that is the reason for the reverse cam box assembly on a PT6. So if you have any questions or concerns, give us a call at Prime Turbines. We'd love to talk to you about any rigging problems or potential engine problems that you're looking at solving, as well as overhaul and hot sections. And thanks for watching.